to the first topic, speed of sound. Now, speed, when we talk about in our general life, we talk about the speed of the vehicle. So, how many kilometers per hour or how many meters per second. Same way, we have the speed of the sound. So, sound also has a speed, right? Now, that is governed by this formula. Speed of the sound is signified by C, which is equal to frequency times wavelength. The speed of the sound is 343 meters per second. Okay, this is the speed of sound. If you are comfortable with kilometers per hour, that will be 1242 kilometers per hour. Now, as we mentioned earlier, this is a low frequency, this is high frequency. How it is different? For a low frequency, the wavelength is higher. See, now you see F is inversely proportional to lambda because C is a constant. The speed of the sound is not going to change. The speed of 343 meters per second is in air, the speed of the sound in air at a normal atmospheric pressure. Okay, the speed of the sound in liquid is going to be higher, in solid is going to be much more higher, right? So the speed is constant, which means only these two can vary. Either frequency can vary, proportionately this can vary. How it is? Proportionately, this is inversely proportional. That is, when frequency higher, the wavelength is going to be lower. And you can see here, this low frequency means the wavelength of this is going to be higher. Same way for high frequency, the wavelength of the signal is going to be lower. See, that is how it is. Now, coming to the speed of the sound, which is 1242 kilometers, let me just relate to the normal speed that we come across. Like you have a motorbike, okay, the maximum speed that you can go about 80, 100, 120 kilometers depending on the horsepower, right? And suppose it's a sports car, maybe it may go at around 200 kilometers per hour, right? 200 kilometers. Now, next higher speed, we take bullet train. Bullet train may be about 350 kilometers per hour. Okay, next, let us take aircraft, the flight that you take between countries. Okay, that is going to go at the speed of about 500 or 600 kilometers per hour, right? And there are some high-speed aircraft which goes above 1242 kilometers per hour. And those aircrafts are called as supersonic aircraft. In aerodynamics, there is a unit something called as Mach. Okay, Mach 1 is this. That is, the speed of the sound is Mach 1. Suppose if anything goes above the speed of the sound, like a supersonic jet, it is going to go at the speed of Mach 1.1, something like that. Now, if you want to say Mach speed for an aircraft, a normal passenger flight, maybe we may say about 0.5 or 0.6 Mach. And here you can see some shaded portion I have put here. Now, what exactly it means is, now low frequency, it has more energy. You see the more shaded area, it signifies more energy is there in the low frequency, whereas for high frequency, the energy content is low. That's why amplifiers, we need big amplifiers to produce low frequency, whereas a very small amplifier is just enough to produce a high frequency signal. So that is a basic difference, and this is how is the relationship between the frequency, wavelength and the speed of the sound.